Okay, so you're taking a course on differential equations. What is a differential equation? Well, an ordinary differential equation, which we'll call an ODE, is an equation that relates an unknown function, so y thought of as a function of x, to one or more of its derivatives. And so the word ordinary here means as opposed to partial, so there's no partial derivatives, or in other words, the unknown function is a function of a single variable y, so we don't need partial derivatives. So let's see what this looks like in practice. So suppose we have some function y equals x e to the 2x. So now if I differentiate this guy, then I see that y prime, by the product rule, is going to be e to the 2x plus 2x e to the 2x. And if I look at this part on the right hand side, I see that this is another copy of y. So this is actually the same thing as y prime equals e to the 2x plus 2y, or in other words, y prime minus 2y equals e to the 2x. And so this is the standard form that we would see for the differential equation. The unknown function y appears on the left-hand side, and so we would take y, or we would consider y to be the dependent variable. So this guy is the dependent, and then x on the other side here is going to be the independent variable. And that's just because y is a function of x, so y depends on x. Let's see. So typically, the way this would work is you would be given the differential equation y prime minus 2y equals e to the 2x, and then by some method, some mysterious method to be yet revealed, you would have to work out the solution that it would have to be. Okay, so we'll look at how to solve differential equations coming up, but right now I just want to point out one easy mistake to avoid. So from the form of it that we had before, you might think, this doesn't look too tricky. I just have to get rid of that derivative there. So I will integrate both sides of this equation. And then when I do that, I'm going to get that y is equal to y squared plus, and then the, oops, I forgot the 2 here, plus 1/2 e to the 2x plus some constant. And there's a mistake there. Do you see what the mistake is? I'll let you think about it for a moment, but just to show you that it cannot possibly be the case that y minus y squared is 1/2 e to the 2x plus c, as I've written above here. Let's take a look. So recall, I actually know what the correct form of y is. So coming from that formula, y minus y squared would be x e to the 2x minus x squared e to the 4x. And there is absolutely no way in heck that these things are going to be equal. Heck no. Okay, so did you spot the mistake? The mistake was in the step right here where I integrated y just using the power rule. So this was as if I was thinking that I could just do y dy equals y squared over 2. But that is not correct, because in fact this is y as a function of x, and so I need to integrate this with respect to dx, and that means we need to be using the chain rule or u substitution for the change of variables. So it's not correct as it's written. So we'll come back and we'll see the proper way to do that later. But first we're going to look at some examples of applications of differential equations in different contexts.